And then this is going to be that hypothetical point. It's the quantity of the non-promoted demand evaluated where? At the promoted price. That point doesn't exist until we create it. Does that make sense? Because that's really the gist of this whole process, is that picture, the slide before that. So, what do? I add in coefficient from non-promoted demand evaluated at the promoted price. And I add in and subtract it so that in the end, it just disappears. So there is non-promoted demand evaluated at promoted price. There is non-promoted demand evaluated at promoted price. Subtracted and added. So in essence, I can add and subtract anything, and the net result is what? Zero. But for this, I'm going to leave it in there. And then I'm just going to collect terms. So I collected my intercepts. I collected my coefficient on X promoted, coefficient on X non-promoted. And then here, I have my coefficients on the difference between the promoted and non-promoted demand curves, evaluated at the promoted price. There's an extra parentheses there. And then here's the difference in prices evaluated on the promoted, non-promoted demand curve. Looks real complicated. But it turns out that that big chunk is the promotion effect, and that little chunk of the equation is the price effect. Now, if firms didn't reduce price when they promoted, then evaluating the promotion effect, this would go to zero, right? Prices would be the same. And then we can just evaluate the vertical distance between these. QN, QP. So if firms didn't reduce price when they promoted, evaluating the promotion effect would be easy. The problem is they do. So this, we're going to have to account for that with that term there. Let's see, did I do it? This is the demand for an anonymous Cabernet. I think it's Mondavi Private Selecto. You can see that the non-promoted price is higher than the promoted, and then I break it down by the individual feature display. So whatever they promote, they reduce price. All right. What did I do? I estimated demand curve for non-promoted, estimated a demand curve for promoted, just like the picture shows. Then I used that big formula to calculate the difference in sales due to promotion and the difference in sales due to price. The total difference, which would be the total lift, which is what you would get if you just compared these 2 points, is about 53%. So this one is relatively small. But if you take out that part due to price, then you're left with that part due to promotion, and this is your true promotional lift. That's your true promotional lift. Now, using that big formula, and again, they're just coefficients, so we know what beta 0 is. It's the intercept of the promoted demand curve. We know what beta 0n is. It's the intercept of the non-promoted demand curve. We know what the beta 1s are. They're the slope coefficients of the promoted and non-promoted demand curves. We know what all these are. These are just coefficients. Take them straight out of Outreg. Do the math. And it turns out that of that 53%, 8% of it was due to promotion. The big chunk of sales, of lift, was due to the fact that they lowered price for this specific scheme.
And do we know that promoted price?
Yes.
So that would be a given.
Yes. Yeah. You have to have these. You have to have those two.
So in this case, it's the $8 and $9.
In this case, it was $8 and $9 exactly. So, normally, the decision on whether or not promotion was effective would be based on the 53%. The true effect is 8%. The true effect of promotion. Pretty simple.
So really that's saying if you didn't promote at all, you would still have 45.22% change
Yep.
in sales?
Yep.
Assuming you change price.
If it's
If you would have
statistically
simply,
significant.
if you would have simply lowered price, you would have increased sales by 45%. The rest of that increase in sales was due to the promotion, 8%.
And depending on the statistical significance, I mean, you can say
Yeah.
that for certain.
No, we'll look at that when we look at all the Outreg stuff. But, yeah, that's the overall gist of this process, decomposing the effective price and promotion.
What's that? What's the percentage composition?
This is just saying that of the 100% lift, of that 53%, 84% of that lift, the 45%, is due to price, and then 15% is due to promotion.
How do you figure that out? Do we have to figure that out?
Well, this is gonna be 100% of this 53%. So if we just put, for example, 45 over 53 would be
I
that,
see.
and then 8 over 53 would be that.
Okay.
It's just putting it in percentage terms.
Mhm.
On top of that, I added something called, or I accounted for something called heterogeneity. I told you in most marketing books, and most economics books, to be honest, if you were to analyze the effects of promotion, you'd get a graph like this, two parallel curves. On top of the decomposition, I also asked the question, what if they're not parallel? What if they look like that? First, what does that mean, that they look like that? This demand curve is steeper than this demand curve. This demand curve is flatter, meaning it's more price responsive. So So what would it mean to have the promoted demand curve flatter than the non-promoted demand curve? What would it mean about the consumers? What consumer behavior? Remember, demand curves are consumer behavior. What are we saying about consumers that buy on promotion, for example?
Capturing more of a prices crowd and a cheaper debate department.
Exactly. That's 100% right. There are some people that will only buy if it's on promotion. That's how they make their decision. Not just wine, toothpaste, soap, whatever it is, they buy whatever's on promotion. And they're more price sensitive. Wine consumers, I would assume, behave similarly to everyone else. And this is a big debate in the literature, and whether or not these two demand curves are parallel. And in the literature, it really were the demand curves parallel? And none of the literature really asked the question, are those two groups of consumers similar? And again, I can think of people that will buy stuff only when it's on promotion. So it made sense to me that this would possibly be true. Now, what could cause it? Well, two things. One is that promotions induce people to behave differently. When I see something on promotion, I buy more of it. That could be true. Or two, promotion induces different consumers into the market. These consumers, some of these consumers, may not be part of this group. They won't buy this product unless it's on promotion. So they're being drawn from some other demand curve, some other product who's not on promotion. And they're gonna bounce from promotion to promotion. Does that sound familiar to anybody? When we go to the wine aisle and we've got 100 SKUs facing us, what are we looking for? A deal. We're looking for a promotion of some sort. We know vaguely the price category we want to go into. So we're really looking at marginal changes. A buck here, a couple bucks there. Get me to buy your product as opposed to one of the other 20 or 30 other products that are the same price category, the same varietal, roughly the same quality. Yeah, we're looking for promotion. To me, that makes sense. From a consumer behavior perspective, it makes sense that those are probably true of the promotional demand. It's gonna be different because either people behave differently when they see promotions, and think of, I don't know if we saw it, no, we did see it this year. We see it every year. The news on Saturday after Black Friday, what do you see in the news? What'd you say? Fights, trampled, people getting trampled. They see promotion, they know Black Friday is a big sale, and they're literally killing other people, stomping over them. Someone got shot in the aisle. Not in the aisle, in the checkout line. Someone got shot. And I think it was a Walmart. It's always a Walmart. It's always a Walmart. Yeah, it's just insane. So it doesn't matter which one of these is true. I think it's probably both of them. What matters is whether or not this is true. But it's a testable hypothesis. All we gotta do is estimate the demands and see if the slopes are similar. And here's the other thing. If the slopes are different, then promotion is gonna have different effects at different points. Look at the promotion effect here. Relatively small. Look at the promotion effect at this lower price. Relatively large. So if those demand curves are different, then the effects of promotion are going to be different at different prices. This is called, oh, I'm gonna need to write it down. This is called the marketing mix. Which combination of price and promotion will give me the biggest bang for my buck? Which combination of price and promotion gives me the biggest bang for my buck? Promotion at this price gives you a very little bang for your buck. Promotion at this price gives you a big bang for your buck. Say that 10 times fast. So trying to find that optimal mix, that optimal price promotion combination, will minimize your expenditures. Will minimize two things. One, it's going to minimize your expenditure on promotion, but two, it's going to minimize the effect, how much you have to lower price. And then two, it's going to maximize your bang for your buck in terms of promotion. This is what mixed marketing modeling is all about. This is the trade promotion answer. This is where you can seriously save money, you get more results for your promotional dollar. I get choked up talking about my own papers like this. It's like talking about one of my kids. So it matters where you evaluate price on what the effect of promotion is. You can't assume this, right? If this is the case, if you got parallel demand curves, then promotion has the same effect no matter where we're at. Evaluate here, the distance between these two curves is always going to be the same. I think that's the definition of parallel, isn't it? I'll Google it. But if they're not parallel, then promotion is going to have different effects at different prices. And think about why promotion wouldn't have a very big effect at the price of P0. What is the price of P0 in this picture?
Higher.
It's high. Yeah. So if you promote, you're almost promoting, look, I'm not on sale. And people that know the products are going to know that. People that buy things regularly know when something's a good deal and when something's a bad deal. We all have these, they're called anchor prices. And in our mind, products are anchored to some value. And we know that when something, when something seems high, we know we can probably get it cheaper another time. So promoting this at this price isn't a very good idea. The opposite's true. We know this is a good deal. Promoting this makes sense. So these psychological anchors that we have for each individual product. And I know that. I know when I see a Russian River Pinot for $12 or $8. Did I tell you the Costco in? Did I tell you guys that one? There's a Costco in crappy town over by the other crappy town. So you got American Canyon, which is a crappy town. And then after American Canyon is what?
Fairfield?
Fairfield. What's even lower than Fairfield? Vallejo, there we go. Vallejo's got a Russian River Pinot Noir that I paid $18 for $8.99. Just insane. But you can't get it at the Costco in Rohnert Park or Santa Rosa or any other Costco. They know nobody in Vallejo.
When you tried it, did it taste the same?
It's the same brand.
Yeah, that doesn't mean.
It could have been a bad shipment or something.
Yeah, sometimes
Yeah.
they'll do different bottling runs for Costco or
Yeah,
Trader.
no, it was good. I've
Yeah.
gone back. I don't go to Vallejo very often. I send my wife back to go. I don't want to get shot or whatever that is. But she's got a bulletproof vest. Back to this stuff. So we know when we know a good deal when we see it. In other words, and that's the whole idea of an anchor price. Heterogeneity and price reductions. Again, we can see here price reduction has a relatively small effect, and then the promotion effect is going to be bigger. So we're gonna do the same decomposition here as we did with parallel demand curves. Up here, we'll see the opposite. If we move to a higher price, we'll see again, right, relative to the promotional effect here, we see a relatively small promotion effect there. Do I have them both at the same time? No. But the point is, we're gonna get different promotion effects depending on what price combination we have, price promotion combination we have. And it turns out, it's not in this presentation, but there's actually a way to calculate the optimum price at which you should promote, that you'll get the biggest bang for your buck. I don't think it's part of your problem set, but it's in the paper. That's why this is such a huge paper. I sent this out to, we write all these papers, and we send them out to publications. I knew this was a good paper when I wrote it. So I sent it to a journal I thought it would be published in. I didn't have usually want to get published as fast as possible. So I sent it out to a journal, and it got rejected. But the rejection was the first kind of rejection I've gotten that said, this paper's too good for our journal. You need to send it to a higher journal. So they told me to send it to the #1 journal in marketing. And I did. And it got rejected from that one, and not for being too good for that one. So I had to find one in between there. So, but yeah, it's just an interesting rejection. This is too good for our journal, send it to a better journal. All right, so here I ran the demand curves. Here's the promoted demand, here's the non-promoted demand. Do the slopes look the same to you? No. And if we look at the regression coefficients, which apparently, they were in the previous slide, but if we look at the regression coefficients, they're different. They're clearly different. So I did the decomposition at a high price, $9, $8, the same $1 price. So I wanted to do a $1 price change. So at the high price, which is the one we did initially, the effect due to promotion was 8%. The effect due to price was 45%. When I evaluated it at a lower price, I just moved that, slid that down. And now the effective promotion is 29%, and the effect due to price is 31%. Which fits my hypothesis. That this demand curve is going to be flatter because people that buy on promotion are more price sensitive. And if they're more price sensitive, they're going to respond stronger to a price reduction, and hence, there's going to be a bigger distance between these demand curves, which is essentially our promotion effect. So promoting at different prices has different effects. Any questions? See if we can actually do this. All right. No questions? Anyone want to see the pictures? Pictures help a lot. That equation helps. You can memorize that equation. But this is really the key picture here. Even though it's got the parallel lines, it's the decomposition that's going to matter. How do we get this point here? And we have a mechanism for doing that. It's called regression analysis. Oh, holy cow, Steve is that? All right. did all this stuff already.
So it's the same data set?
It's the exact same data set, we're just going to do the decomposition. So we're already set up to do this. Mass estimates. Okay. Regression. So here's the regression. What is this? This is price, promotion, and then an interaction with price and promotion. We're ignoring months right now. And we can see that, let's see, the interaction between price and promotion is, bless you, is 945. And it's statistically significant. What does that tell us? So what is that? What does this term tell us?
That's how many cases you're gonna sell when it's promoted and the price is reduced.
As you increase by $1, you're gonna sell less, 945, right?
Well, what's that price then?
Price increase without promotion.
That's, so if this was eighth grade algebra, this is what?
That's the y-intercept.
No, it's
No.
it's a slope, right?
Right, that's the demand curve.
But it's a slope of what? Not that. Let's try this one. We got two demand curves, non-promoted, and then we've got promoted.
Non-promoted. Get your promotion on non.
So what is the number 708 first?
Slope
Slope of what?
of the non-promoted.
Of the non-promoted. Perfect. So it's the slope of the non-promoted. It's this here. How responsive non-promoted consumers are to changes in price, which is the definition of our slope. So what is this term?
Slope of the promotion.
It's the slope of the promoted?
I'm saying C is C for constant. Are
Where's
you
the
holding
C?
price
But you have your
constant? What's
prices
the
It's,
stand for?
it's an interaction, right?
Yeah, it's
Right.
the price
Your
and
price.
promoted together.
So how do we always interpret a dummy variable?
Shift.
Multiplication. Yeah,
As a difference, right? So in this case, it's an interaction with price, so it's a difference in what?
The full price and promotion price.
Difference in slopes? This tells us that the promoted demand curve is more negative than the non-promoted demand curve. In other words, people are more responsive. For example, for a $1 increase in price on the non-promoted demand curve, they buy 700 fewer cases. For a $1 increase in price on the promoted demand curve, they're gonna buy 708 fewer cases, as well as 945 more fewer cases. So they're more price responsive. So it's the slope of the promoted demand curve. So this tells us that the promoted demand curve is more responsive to price changes than the non-promoted demand curve. And that difference is statistically significant.
So price is the slope for DN and negative 945 is the slope for DP?
No,
It's the difference,
it's the difference in the slopes.
okay.
So the slope of,
So we don't know what the slope is for DP?
can we find out?
I'm sure we can.
So if it's the difference in the slope, so if we know the slope of the demand, of the non-promoted demand curve, and we know the difference in the slope between the demand, between the promoted and non-promoted, how would we find the slope of the promoted? Do what?
Add them together.
Add them together. So it'd be negative 708 minus 945, which is something more negative. Does that make sense? And the reason we want to establish this, I didn't draw these very well. Let's try one. The reason we want to establish that is because if the slopes differ, then price and promotion will have different effects at different points. Not all promotions are going to be equal. You have to find the optimum price promotion combination. If the slopes were the same, if this difference was small and statistically insignificant, small t, then we can say that the two demand curves are parallel. Consumers in both that buy on promotion and non-promoted and off promotion behave similarly. If that's the case, then promotion is going to have the same effect no matter what price. So there is no optimal price promotion combination.
And that would be only if the change in slope was not statistically significant.
Correct. So the fact that it is, and it's by the way, it's a lot more negative, right? We're not adding a small number. It's more than twice the size, more than twice as responsive. And again, it's not sure if this is sinking in, but because of that, you've got to find the optimal price promotion combination. It's in, when the lines are parallel, we were already measuring promotional lift wrong. Throw on top of that, they're not parallel. Not only do we add in the fact that we need to measure promotion more correctly, my method, my decomposition, but now we also have to find the optimal price promotion combination. This has been an issue that, this is called marketing mix model. This has been an issue that is. So we've established that the two demand curves are different. Now we just have to follow that process. We just have to, oops. Following that process, we can find out this point, and this point, the next slide over. We'll be able to at least measure promotion more accurately. And get a true promotional lift, as opposed to that conflated promotional lift that is used by every other firm in the world that hasn't read my paper. Firms don't read papers. Any questions? No?
Have we figured out the Q0, 2, and 1 via through that other regression that you did?
No, not yet.
Not yet.
We're gonna do it right now though. Because we need to find a price, right? So all we've done so far is estimate the demand curves and establish that they're different, that their slopes are different, that they're not parallel. So that's good. And that, like I said, in the literature, in the marketing literature, when I was writing this paper, there was a big debate going back and forth, and most people just said, well, just treat them as parallel. It doesn't matter, but it does matter.
But if they were parallel, the numbers both would have been 708, is that correct? -7 if they were parallel.
Correct. Then this number would be relatively small, I'm sorry, relatively small and statistically insignificant. T less than something. And we tripped over that squid stool. Oh, it's over there. Just about to say I went the whole semester without tripping over it. Watch out, trip. Jinx myself. Fall out the window. All right, so now let's do a decomposition. Before we do a decomposition, we have to pick a price. Promoted and non-promoted price. So we'll just follow what we did in the paper. Since this is the data I used in the paper. We used in the paper. Okay, so what do we do? I'm going to estimate two demand curves. So, just gonna estimate a promoted one, estimate a non-promoted one. Once we get all these coefficients, then we can find these points here on the little slide. I guess that kind of works out conveniently.
And we decided that X was not something we were gonna mess with, right?
X would be month dummies, they could be region dummies, they could be, yeah, it's a shorthand for all the other stuff that you can throw in a demand curve. But right now, we're not gonna deal with it. So, what do? I estimate a demand curve for promoted demand. Right? P promo equals 1. So this is the promoted demand curve, slope of 1653. And then I just switch that 1 to 0. So what do I have? I've got beta 0p, beta 1p. Then I've got I estimated demand curve for non-promoted, switch that to a 0. I've got beta 0 n for non-promoted, and I got beta 1, the slope of the promoted demand curve. Let's see, I can outreg this. My regressions. Decomposition, that sounds like this. All right, so I outregged it. I've got my constant beta zeros, and I got my slope coefficients, my beta 1s. I'm going to pick two prices, $8 and $9, and I'm going to evaluate. So here's $9, here's $8, I evaluate the non-promoted demand at $8, at $9, excuse me, that'll give me QN. And if I evaluate the promoted demand at $8, it'll give me QP. All I need to do is evaluate the non-promoted demand at $8, and that'll give me QN at the promoted price. Price. Due to promotion. Have we done this before? Have we done anything like this before? What's that? Have we ever evaluated a demand curve at the price? A couple hundred times, haven't we? We just do what? The constant plus minus the price times the coefficient on price times A price, right? We've done that a bunch of times. So we're not doing anything that we haven't done before. So let's start with this. And I just made this little table. Column E is non-promoted demand, or is the promoted price, and then column F is the non-promoted price. So let's do this. Yeah, this is fine. Non-promoted demand equals the non-promoted constant plus the non-promoted price coefficient times what?
Price.
Yeah, times price. And let's do $8, since we're in the $8 cell. The non-promoted demand evaluated at the non-promoted price is again the same thing. It's constant beta 0 plus beta 1 times the non-promoted price, which will give us, whoops, 1979. This is the promoted demand evaluated at the promoted price. Is that right? Looks right. So, the amount due to price is, let's see, the difference between the non-promoted demand at the non-promoted price and the non-promoted demand evaluated at the promoted price. These 2 points, right? Is that right? Close? Right-ish? What is that? 2688, let's go back, 1979 is non-promoted demand evaluated at non-promoted price. 2688 is non-promoted demand evaluated at the promoted price of $8. The difference between those two is 708 cases. And what we're left with is the promoted demand evaluated at the promoted price, which is this term way out here. And if we subtract out the non-promoted demand evaluated at the promoted price, we just take the difference between these two, that'll give us our lift due to promotion. And that's that term right there. And that's the 761 cases. So, in this case, we have a total lift of 74%, but roughly half of it, or 38%, is due to promotion and 35% is due to price. Does that make sense? This is the outright version. We could have also done this another way. How else could we have done this?
You've done it with margins?
These words.
Margins. The whole point of margins is it'll predict for specific prices, right? So we could have done that. But the key is, again, understanding the decomposition itself. Isolating the effect due to price and the effect due to promotion. And these are things contained in the data. We're gonna know when you have a sale, when you have a promotion, you're gonna have to find out a promoted price. And you're gonna have this information on hand. We're gonna, yeah, that's that promotion, we lowered price to this. So you should be able to do this for any product that you have data on. So let's go back to the bane of all your existence, Stata. All right, so let's see. Gotta make sure we're doing the right regression decomposition. Promoted, so we need a non-promoted demand curve. There it is. Oh, there it is right there. So it's highlighted, and the nice thing about margins is that you can select as many prices as you want. I selected prices of 8 and 9. Getting the exact same numbers. And let's see, this is the, scroll down 1 second. Scroll up 1 second. This is the non-promoted demand. You can tell because it says D promo equals 0. All right. And we have two prices, price 1 and price 2. Price 1 is $8, so it's non-promoted demand evaluated at the promoted price. Non-promoted demand evaluated at the non-promoted price, so $9. Are these the same numbers we got earlier? I hope so. If they're not, I have to edit the paper. But they should. So we got these using margins. now we have to estimate the promoted demand. So we've got this non-promoted demand at the non-promoted price, non-promoted demand at the promoted price. We need to estimate the demand curve, the promoted demand curve, and evaluate it at the promoted price. And you're picking $8 and $9 because they're round numbers, as opposed to $8.99 or whatever. So, promoted demand, it's got the D equals 1. Margins evaluates the promoted demand at the lower promoted price, that's our $34.99, $34.49, excuse me. And just subtract. And subtract. Display due to lift should be that same 708. Display due to promotion. And if we took the percentage change, we get those same percentages. How would we get the percentage lift? How would we get the percentage lift? How would we get the percentage lift?
Divided by the non-promoted price.
Divide by the quantity at the non-promoted quantity at the non-promoted price. So it's our percentage change from here. What percent is that, and then what percent is that?
What's the difference in the effects?
What's that?
What's the difference in the effects, basically? Like if you said, yeah, the promotion effect on the right hand side of that picture over there, and then the price effect, so the difference of those in percentage terms would be,
Yeah, percentage lift, exactly. So it would be, let's see, our promotion due to, I'm forgetting which, I think this is due to price, no, promotion. Or we can just divide it by the total. Let's see. So that's the total lift. Right? 1%. 38%. These are all the right ones, yeah, they're all the same numbers. Put them in on. What was the non-promoted sales? Oh, I know, it's in the margins. What is that? Second price was higher. So that's the non-promoted sales at the non-promoted price. Which was our 38%. pretty simple when it boils down to it. No questions? Well, either one of two things is going on. Either there are no questions and you all get it, or there are no questions and you all don't get it, but aren't gonna do it. So it doesn't matter. Either way, we're done. I mean, that's the end.
Will you go back to your Excel file one more time and explain that second? I get the 38%, I understand that.
The second, this one?
I get the first one, the 3845.
Mm-hmm.
Would you explain the 708 one?
The
That's
708 is.
to the percent, what am I looking at?
Yeah, so in that one, you're looking at the lifts due to price over really the same, they're both over the same,
Are they over the same number?
yeah.
Non-promoted.
So if you look at this, it's,
1979,
Oops.
708 over 1979, and 761 over 1979.
correct, they're all over 1979, which is the starting point, right?
The non-promoted.
Our starting point is non-promoted demand at the non-promoted price is here. So what's this divided by that, and then what's that divided by that? And the picture's a little bit misleading because this is probably bigger than those. Make sense? A little bit? Yeah. Perhaps?